Hi everyone, last time a year 10 student told me he forgot his calculator when attending a maths exam. So he skipped a question on evaluating a square root to 4 sig figures, and he lost 2 marks. Today, I will be showing you a method how to manually evaluate a square root without using a calculator, although you still need to be proficient in your long divisions. At the end, you also might be able to do the last question in one of the 4-unit HSC past paper. There are different methods. The method I'm going to use is called continued fraction. So a fraction keeps going forever. Say we want to find the general expression of root s, where s is a positive integer, which means we are able to rewrite this as a squared plus b, where a is called a largest possible perfect square and b is the positive residual. I forgot what the exact question he missed in the exam, but let's say take root 190. So 190 can be rewritten as 169 plus 21, which is 13 squared plus 21. To get where the root s coming from this equation, we are able to apply simple algebra and factorization. For example, by moving the a square over, we are able to using difference of the 2 square. Believe everyone can do that, and move the root s plus a over to the denominator, and then we can make root s the subject, something like that. Now, we are able to see root s appear again in the denominator. So here, where root s is the original equation, which means we can sub it back in again. So I'm going to use a red pen to represent the new thing I sub in, which is a plus b over a plus root s again. By repeating this process forever, we are able to get our desired expression, something like that. So let's simplify the a plus a into 2a and b over 2a plus dot dot dot. So firstly, we are able to rewrite the square root of 190 into a, which is 30, plus b onto a, 2 times 13, 26, plus b onto a, plus dot dot dot, which is approximately 13.78404.875. That is the answer, but we do not know that. So let's take the zeroth level, which is defined as the letter A from the general formula. In this case, we are saying it is going to be approximately 13, which is true. To be more accurate, we are able to use the first level, which is defined as a plus b onto a. We have a plus b onto a, which is 13 plus 21 over 26, which gives you 13.80769.231. It's getting more closer, but it's still not accurate up to 4 sig figures yet. Let's take one more level, which is called the second level here. And we're going to have something like this, approximately 13.78335725. As you can see, it's already correct up to 4 sig figures, which means he could save him 2 marks by knowing this algorithm. Surprisingly, knowing the nature of the square root well will allow you to try one of the last questions in a 4-unit HSC past paper. The question is coming from 2012 question 16 part III, and it's like this. It's not too long, so I'm going to write it down. If square root n plus a quarter is bigger than k minus half, where n and k are integers, prove root n is bigger than k minus half. You can pause the video if you want to attempt the question. We can start off by squaring both sides, something like that. Since, if you look at the answer, we want to somehow get rid of a quarter in the square root. So, we are able to simply expand it. Square root cancels, perfect square, something like that. And a quarter cancels. Now, the most important thing you need to realize is, since both sides are integers, which means n has to be greater than k squared minus k by at least 1. In other words, if you look at the answer, which is the minus half, you are wondering where it's coming from. We can achieve this by plus another quarter on the right-hand side to make a completing the square, which is something like that. Now, by square root both sides again, you are able to get your answer. Thank you for watching.